Hello, I'm Sophie Bartlett. I'm a research associate at Cardiff University in the UK. Previously, I did an undergraduate in astronomy and then I completed my PhD in physics and astronomy education. And today I'm going to be talking about this PhD research and the advantages of using mixed methods for evaluating astronomy resources. So the title of my PhD was an evaluation of secondary school students' learning experiences with astronomy-based physics outreach activities. And I developed a series of astronomy activities and sought to answer the following questions. How are students' perceptions of positive learning experiences promoted within a physics lesson? How does teachers' planning and delivery of these astronomy activities influence these learning experiences? And then what are the implications for future development and utilisation of astronomy activities? So just to give you a brief overview of the astronomy activities, these were designed by myself and were intended to be delivered by teachers to students in their classroom. All the activities were investigative by nature, so I structured them as teacher packages that included a number of components. They included lesson plans, so this provided suggestions and tips to teachers of how they should be implemented, whether in group work or with individual students, and some rough timeframes of how long each component should take. I also highlighted how the activities applied directly to the curriculum so they could help with the timetabling of their lessons throughout the academic year. The background information was provided so that teachers didn't need to do any further research or any background reading ahead of their lesson, and it was all provided to them by myself. The student worksheets were provided for students to record their observations from doing their investigations and to record some of their workings and their answers. I then also provided a teacher guide that gave them an idea of what kind of answers the students themselves should be getting. And then I also provided an introductory PowerPoint presentation. This was for in case the teacher wanted to do a brief introduction to the students before they started their investigation. And all of these material were provided in editable format so the teachers could pick and choose which parts they wanted to use and cut out or add anything. So, in terms of my method to address my research questions and assess students' learning experiences, I employed a mixed method research design. So the reason I did this was because I wanted to use both quantitative and qualitative methods to gain a more holistic understanding of what was happening in these classrooms. And it also meant that it would surmount the limitations of just using a single paradigm. I also employed a sequential explanatory design. This is where I employed the quantitative methods first. This identified what happened, and I used my findings from that to inform the next stage that was qualitative, and this helped me to answer why that happened. I also employed a multiple case study design. So this meant that each classroom that was experiencing these astronomy activities acted as a case. So I collected individual data from each of these cases, and that provided an individual context in each scenario. So for the quantitative methods, I used a questionnaire designed to measure students' perceptions. This was implemented on 2 occasions. Before any engagement with the astronomy activities, to gauge their perceptions of their day-to-day physics lessons, and again after completing the astronomy activities, to gauge their perception of the activity itself. The questionnaire was designed to measure 5 key areas, all of which were designed to reveal students' views and perceptions around the 2 contexts. This questionnaire was completed by all consenting students using the astronomy activities and was advantageous because it provided a tool that could be used in other or future resources to permit direct comparisons in the future. For the qualitative methods, I used classroom observations, focus groups, and teacher interviews with a smaller subset of my audience. The observations were carried out before implementation, so during day-to-day physics lessons, and again while students were carrying out the astronomy activity. The focus groups and interviews were carried out after the implementation activities, and in line with the sequential design, the question schedules for these focus groups and interviews were informed and guided by preliminary results from my initial observations and from the questionnaires. This allowed me to further explore why such events took place and why students were or were not engaged as they'd indicated in their questionnaires. For the observations, I recorded a number of elements, and this formed into 2 parts. The demographics and delivery, so this covered just the general demographics of the classroom and the school and the students in terms of gender and age. And then also an overview of how the delivery happened, so how the teacher implemented the specific activity in their classroom. Then for the action protocol, this was broken down into these 10 key elements here. And this provided me with much more details on how this was actually implemented in practice. Although I don't have time to go through all of my results, I'm able to give you just a brief overview of what I did. So for all my quantitative data, I performed statistical tests, and for all of my qualitative data, I performed thematic analysis. I then performed a case-by-case review. So in each instance and classroom where the activities were implemented, I investigated the data that I'd collected in that context individually. This turned out to be really important because although each case implemented the exact same activities, the teachers in each scenario implemented it in a slightly different way, and this obviously had an impact on how they were perceived by the students and their learning experiences. Then at the end, I triangulated all of the data to look at any commonalities or differences. So the table here shows you the results of a t-test that was computed to explore questionnaire results between students' perceptions towards physics lessons and towards the activities. And as you can see here, I found that there were significant differences for 3 out of the 5 areas. Then the qualitative data allowed me to explore this further. So why was it just these 3 that we saw differences for? Why not the other 2? And what exact experiences were the students having that led to these differences between these 2 occasions? At the bottom here, I've also provided just an example of a quote that I analysed, and I've broken it down into different components. So this is where I would have coded the quotes, and then they would have formed the larger themes at the end. So if we now go back to my initial research questions, this study identified 5 key elements that promoted positive learning experiences among students. Each is accompanied here by an example quote from a student participant. And although identified in the context of astronomy activities, I believe that such elements are applicable to any activity or resource. So the components here were investigation, so going through the scientific process to gain new knowledge. This also linked closely with the experiences of autonomy, so providing a student-centred classroom rather than a teacher-centred one that gives students a sense of control over their learning. Novel experiences that are surprising and provide a wow factor were really important to trigger their interest, especially when there wasn't any there already. Cooperation and collaboration with peers provide students with a sense of relatedness and belonging in a science environment. And then differentiation was key in promoting student confidence, making sure that the activities were challenging but also still felt capable for the students to achieve. So in terms of the impact of planning and delivery, despite the opportunities for autonomy in a student-centred classroom, the role of the teacher was still crucial in guiding students' experiences. The use of multiple case studies where each classroom implemented the same activity but in a slightly different way was a huge demonstration of the influence of the teacher's role despite what the activity was. So where teachers had a highly positive relationship with their students and awareness of their individual learning needs, they were able to adapt the materials, and this helped hugely with differentiating activities for mixed ability classes. Also, the level of planning that the teachers did beforehand is demonstrative of this figure below. So where teachers had no prior preparation and only looked at the activities on the day of implementation, these were much less successful than those who had actually been through the activity themselves prior to doing it with their students, and better still, those who implemented it with more than one classroom, so they had repeated experience of delivery. So in terms of my final research question, in terms of the implication for future resources, and perhaps a summary of all the research that I did. So the key thing that I found was that no matter how much guidance and structure you provide to the teachers, any activity will be implemented slightly differently in every classroom, and that's something for educationalists to be aware of. I recommend embedding the 5 key components that are listed in this box here, as these were found to promote positive learning experiences among the students. It's really crucial to consider the role of the teacher and identify the support that they need. Everything that you can do to help them and reduce the workload on their part is only going to help implementation and encourage more positive learning experiences. I would suggest trying to provide a resource that's what I call off-the-shelf teacher packages. So this again provides a number of activities where you can structure it so they're slightly different versions and they're differentiated in order to meet the different needs of students. Then the teachers can pick and choose which one they think is most appropriate to their classroom. and also including progressive objectives. Teachers really like to see objectives so that they can clearly identify what the learning goals are for the activity, and they can also tie it back to the curriculum. This can also help them identify areas of differentiation. So providing objectives that are progressive, they can maybe pick one or two if they think the students are perhaps of lower ability and include 3 or 4 of those who are of higher ability. So thank you for listening, and I hope it was useful intel into my research study and perhaps even give some food for thought for any evaluation of astronomy activities you do in the future. I'd be happy to take any questions, or if you would like to contact me for any more information, please email me on the address provided. Thank you.